my name is Abdi Samad, and this presentation is my proposal for a web application called FitTrack Web. FitTrack Web is a cloud-based fitness tracker that allows users to log their workouts, count their calories, count their steps through a simple web interface. In this presentation, I'll be covering the motivation of the project, the web application architecture, and the role of cloud computing, and how the design maps to the learning outcomes. FitTrack Web is designed as a responsive web application that helps users monitor their daily physical activity. Instead of being a native mobile app, it runs on the browser, so it can be accessed from laptops, tablets, and smartphones without installing anything. In today's world, many people are aware that they should move more, but they often lack a simple central place to record their activity. This project aims to provide that kind of simple, accessible tool, focusing on core fitness metrics such as workouts, calories, and step counts. The main problem that I'm addressing is that people struggle to maintain consistent fitness habits and don't have clear visibility of their day-to-day activity. Many existing fitness apps are either very complex, tied to a specific device like a smartwatch, or they split the data across multiple tools. For example, one app for steps and another one for workout logging. This can be confusing for beginners and for users who just want something lightweight. So FitTrack Web is relevant because it offers a single browser-based hub for logging basic activity and seeing progress, without requiring specialist hardware or a heavy native app. This project has several key objectives. First, to design a coherent web application that allows users to log workouts, step counts, and calorie estimates in an intuitive way. Second, to provide users with clear feedback, including daily and weekly summaries of their activity. Third, to ensure that the underlying architecture supports scalability, maintainability, and acceptable performance as the number of users and fitness logs increase. Another objective is to create a mobile responsive interface, so the application can be comfortably used on smaller screens. And finally, I aim to integrate cloud-hosted services so that all user data is stored securely online and can be accessed from any device with an internet connection. The general target audience for FitTrack Web is general gym goers who want a straightforward way to track their activity and might not want to just install yet another native app. They're comfortable using technology, but they prefer quick, simple interfaces that they can open on a browser, for example, on a laptop at home or a phone on the go. Specific use cases now include a student logging into their gym sessions and their daily steps at the end of the day, an office worker recording lunchtime walks and checking their weekly totals, or a user setting up a daily step goal and monitoring how they reach it. These use cases that influence the UI and UX decisions, such as the emphasis on simple forms, clear navigation, and a dashboard that immediately shows today's progress. Now moving on to the web application architecture. At the top here, we have the client layer, which runs in the user's browser and is built using HTML, CSS, and JavaScript. This layer is responsible for the user interface, form handling, and updating the dashboard dynamically. The client communicates with the application layer, which is the backend running on a web server. I plan to implement this using PHP. Behind the backend is the data layer, which is a relational database like MySQL. I will use a users table to store account information and a workouts table to store each user's activity logs, including date, type, duration of workout, calories, and step count. All of this will run on cloud infrastructure. The core features of FitTrack Web revolves around three main actions. First of all, users can register and log in securely by creating a personal account. Secondly, they can log workouts by selecting a date, choosing a workout type, entering the duration, and optionally, an estimated calorie value of some notes. Thirdly, they can log their daily step count, so the system can calculate daily and weekly step total. On top of these core features, there are a few value-adding features. The application can calculate activity streaks, such as how many days in a row the user has logged in. The app also provides basic analytics such as average daily steps or total calories burned. These features help motivate users and also provide interesting data for analysis in terms of performance and resource use. Here we have some initial design concepts. The login screen contains a simple centered form for email and password with a clear link to register for new users. Once logged in, the user is taken to the dashboard. The dashboard displays today's summary, including steps, workout times, calories burned, and lists recent activities. It will also provide quick access buttons to log a new workout or log steps. The logout workout screen is a clean form where the user selects a date, workout type, duration, and calories, plus optional notes. The focus is on a large, easy-to-use inputs that work well on mobile. The progress screen presents a weekly summary, total steps, total workouts, and total times, along with a simple visual trend by day. Overall, the user experience aims to minimize friction so that recording activity becomes a daily habit. For the technology stack, the front end will be built with HTML, CSS, and JavaScript. HTML provides the structure of the pages, and CSS handles layouts and styling very well. And JavaScript manages interactivity and dynamic content, such as updating the dashboard when new workouts are logged. For the backend, I intend to use PHP, as it's widely used for web development and will integrate well with MySQL. The backend will implement the main business logic and expose APIs for the front end to call. The database will be MySQL, which is a relational database system for storing structured data such as users and workouts, and supports indexing and efficient querying. The entire application, including the backend and database, will be hosted on a cloud platform. This allows for managed infrastructure, easy deployment, and potential scaling in the future. From a performance and analysis perspective, the main consideration is the growth of the workout data over time. Each user can log multiple workouts and step entries per day, which means that the workout table could become quite large as the system gains users. So, to maintain good performance, I plan to use indexes on key fields such as user ID and date, so that queries for specific users' data over a given time range. For example, this week's workouts are efficient. Potential bottlenecks include high read load on the database when many users load dashboards simultaneously, and any poorly optimized queries that scan the tables rather than using indexes. As part of the analysis, I would examine response times for loading the dashboard and monitor resource utilization on the server during testing. Cloud computing plays a central role in the design of FitTrack Web. By hosting the application and database in the cloud, users can access their fitness data from any device with a browser, without being tied to a particular machine. The cloud also supports scalability because resources can be increased as the number of users grow, and it offers high availability through managed infrastructure backups. There are some challenges, however. Fitness and activity data is personal, so security and privacy are critical. Data protection regulations must be considered when deciding where and how to store user data. Also, users depend both on internet connectivity and the uptime of the cloud provider to access the application. Understanding these benefits and challenges is an important part of providing the best application. With regards to the project timeline, in weeks 1 and 2, I plan to research existing fitness trackers, gather requirements, and finalize the feature set. Weeks 3 and 4 will be focused on creating detailed wireframes and refining the user interface and the user experience design, and confirming the architecture. Week 5 to 7 will be used to develop the front-end pages, including the login screen, dashboard, and login forms. In weeks 8 and 9, I will implement the back-end APIs and set up the MySQL database and connect the front end to the back end. Week 10 will be used for integration, testing the full workflow end to end. And finally, weeks 11 and 12 will be focused on performance checks, polishing the user interface, and preparing the demonstration. In conclusion, FitTrack Web aims to provide a simple cloud-based fitness tracking solution that addresses a real need, while providing a simple and easy experience for users. Thank you for listening.